Hello everyone, today in this video we are going to solve some question on electric field of a dipole. So after this video you should be able to calculate the electric field at axial and equatorial line of a dipole. So before we solve the question, let's do a quick recap on electric dipole. So electric dipole is equal and opposite charges separated by a small distance 2a, and electrical dipole moment is given by either charge into distance between the charges. So q is charge and 2a is the distance between the charges, and electric dipole moment is a vector quantity and its direction is from negative charge to positive charge, and unit of electric dipole moment is coulomb meter. And now this is the expression for electric field at a point on axial line of a dipole, and this expression is when r and a, this distance r, and the length of the dipole is comparable, and if the dipole is short or distance r is greater than the distance a, then this formula can be modified into this formula. We can neglect this a square. And now for equatorial line, electric field is given by this expression when r and a are comparable, and if the dipole is short, that means this distance r is long as compared to this a, then this formula is simplified into this form. And if we compare the electric field at the same distance at equatorial point and axial point, then the formula is given by this. Electric field at axial line is 2 times the electric field at the equatorial line for the same distance. So now this is the first question. Two charges plus 5 microcoulomb and minus 5 microcoulomb are separated by a distance of 1 millimeter. Calculate the electric dipole moment. So charge is given. Now we have to convert this into coulomb because microcoulomb is not the SI unit, and the distance of the dipole, that is 2a, is given, that is 1 millimeter, and you can convert this into meter. Now we know the formula for electric dipole moment is 2aq. When we put the values and solve this, we get dipole moment to be 5 into 10 to the power minus 19, and you know the unit of electric dipole moment. And this is the similar question. An electric dipole with charge plus minus 4 microcoulomb is separated by a distance of 5 millimeter. Calculate the electric dipole moment and give its direction. Following the same procedure, you can find the electric dipole moment. So this is the answer, and direction is always from negative charge to positive charge. So I can write the direction of electric dipole moment is from minus 4 microcoulomb to plus 4 microcoulomb. And this is the second question. Calculate the electric field due to an electric dipole of length 10 centimeter having a charge of 1 microcoulomb at an equatorial point 12 centimeter from the center of the dipole. Out here charge is given, that is 1 microcoulomb, so you can convert this into coulomb, and length of the dipole is given 10 centimeter, and you have to convert this into meter, and you can find a also. Now r is also given 12 centimeter, and you have to convert this into meter. Now this is the expression for electric field, and this is for when r and a are comparable, and this is when r is greater than a. Now if you see, r is 12 centimeter and a is half of 10 centimeter, that is 5 centimeter. Both are in centimeter, so they are comparable. So we have to use this formula. So now you can put the values and you will get this to be your answer. And this is another question. 2 point charges 1 microcoulomb each but opposite in sign, that means plus minus 1, are separated by a distance of 4 centimeter. Calculate the electric field intensity at a point distance 4 centimeter from the midpoint of the axial line. So out here charge is given, length of a dipole is given, so you can find a, and r is 4 centimeter. Now if you see, a is 2 centimeter and r is 4 centimeter, that means they are comparable. So for comparable we use this formula. So we are finding the electric field at axial line, and if you put the values, you will get the answer. This is another question. 2 point charges plus minus 0.2 microcoulomb are separated by a distance of 10 to the power minus 8 meter. Calculate the electric field at axial point at a distance of 0.1 meter from their midpoint, and next is at equatorial point at a distance of 0.1 meter from their midpoint. So out here the distances are not comparable, so our distance r is greater than a, so you have to use the second formula for finding the electric field at axial point and equatorial point. So you can try it by yourself. And this is the second question. Calculate the electric field due to an electric dipole of length 10 cm and charge plus minus 100 microcoulomb at a point of 20 cm from each charge. So it is saying the distance is 20 cm from each charge. So it is not saying whether it is axial line or equatorial line, but it is saying the distance is 20 cm from each charge. So if you draw this diagram, then you see 20 cm from each charge will be the point at equatorial line. So using the Pythagoras theorem you can find the distance r, and you can see this 10 cm and 20 cm are comparable. So you have to use the expression where r and a are comparable. Now you can try this question.